This video we're going to look at how to find the horizontal asymptotes of rational functions. If the degree of the numerator is greater than the degree of the denominator, then we are not going to have a horizontal asymptote. If the degree of the numerator is less than degree of the denominator, then we're going to have one horizontal asymptote at y is equals to 0. If the degree of the numerator and the degree of the denominator are equal, then we have one horizontal asymptote, which is y equal to the ratio of the leading coefficients of numerator and denominator. So we look at the first one. So I check the degree, and here I see the degree of top is less than degree of the bottom. So that means the asymptote, the horizontal asymptote, does not exist. So I'm going to write here, does not exist. Or I can just write no horizontal asymptote. No horizontal asymptote. So that's the answer. Okay, I go to the next one. So the degree of the top is also less than, it's also more than the degree of the bottom. And I'm going to say here, there is no horizontal asymptote. So no horizontal asymptote. That's the meaning of HA. Then I'm going to go to the next one. I compare the degrees, and here I see the degree of the bottom is more than degree of the top. So that means the asymptote is going to be y is equals to 0 always. The next one here, I see the degrees are equal. So that means there is a horizontal asymptote given by the coefficients of the leading of the degree, the leading coefficients, ratio of the leading coefficients. So this is 6/3, which is equals to 2. So y is equals to 2. I'm going to dig deeper just a little bit and talk about the horizontal asymptotes in the first two examples. Here, the degree of the top, compare the degree of top and the degree of the bottom. Because when the difference is just 1, then that means that we have a slanted asymptote. Slant asymptote. We have a slanted asymptote. The next one here, I see the degree is of the top is more by 2. So this one I'm not going to have a horizontal asymptote, no slanted asymptote. There is no asymptote at all. So this one is no asymptote. Not even a slanted one. Actually, what will happen, this function will have the same behavior as a polynomial, which you're going to get by simplifying this fraction. And in this case, if I simplify the dominating terms and 2x cubed, I get 3/2x squared. So this function will have the same behavior, add behavior, as this polynomial.